The Chancellor, His Excellency Dr. Thabo Mbeki, the Vice Chancellor and Principal of the University of South Africa, Professor Puleng Linkabule, to the professor that we are inaugurating today, Professor Linda Linganiso, her family, members, friends, and loved ones, members of the College of Engineering, Science and Technology, and the staff, the Executive Dean and his staff, administrative staff, colleagues, UNISA students, students from other higher education institutions, supporters, funders, UNISA alumni, distinguished guests, boys and girls, and most importantly again, to you, Professor Linganiso, our celebrity of the day, Molweni, Sanbonan, Tobelang, Dumelang. Good afternoon into the evening, Jambo. I acknowledge all protocol. My name is Professor Tenjiwe Meyiwa. I'm the Vice Principal responsible for research, postgraduate studies, innovation, and commercialization here at UNISA. Ladies and gentlemen, greetings. Welcome to Professor Linganiso's inaugural lecture. We are installing her. She's a full professor now. That's exciting. She's a professor at the Institute of Catalysis and Energy Solutions at the College of Science, Engineering, and Technology. I recognize her family who are part of this gathering and thank them for a significant role that they have played in her scholarship. Sometimes all indeed that you need is a family that is and has been as supporting and providing the kind of environment that they've provided to Prof. Linda. Please allow me to also single-handedly acknowledge the Executive Dean of the College of Science, Engineering and Technology, Professor Mamba, who is participating actively on this evening's program. We also have to welcome and appreciate Professor Sabelo Mhlanga, the Managing Director and CEO at Sabi Nano Pty Ltd, and also a Research Associate at the Nelson Mandela University. Prof. Sabelo, we thank you for heeding our call as a respondent for this lecture. As an institution, the commitment we have for solutions to problems that we face is significant. And its significance is coupled with our celebration when we have professors that have walked the path on the path towards finding these solutions. Solutions of injustice, solutions of the wrongs within our systems, and solutions of the wrongs that Prof. Linganiso identifies in her work. And therefore, we are expecting that what these professors like Prof. Linda has done, pass on what they have gathered over the years through their scholarship and their research projects to their postgraduate students. And indeed, Prof. Linda has done just that. It is for that reason that we are in such a celebratory mode. We're very proud of you, Prof. Linda, for reaching the full professorial status. What is a professor a full professor for that matter. It's somebody who's done just exactly what Linda has done. Prof. Linganiso has produced the kind of research that we expect, has sourced and secured funding in the millions of rands that she has done, and has raised mentees at the level that is going to be equal to what she herself has achieved. And for that, we applaud her. In applauding her through the chat box, as you congratulate her, go beyond that, ladies and gentlemen. Also give her ideas, some pointers of what she may need to go for in her future research based on the experiences that you are having on the ground as the society, as the global people, because we have a lot of such, and we need researchers to find solutions to the problems that we experience on a daily basis. Now, Professor Linganiso's lecture, which the executive dean, not acting, the executive dean, Professor Mamba, shall provide a brief on, very much is a resounding call that the African Union has made at the national level as well as at the continental level for each and every country, that we need to find solutions to the problems that we have on the continent and in our communities. Ladies and gentlemen, as I talk about Prof. Mamba, he is about to ascend the stage as he presents the work of Prof. Linganiso, briefly, her bio. Prof. Mamba, onto the stage, please, sir.
The Chancellor of the University of South Africa in absentia, His Excellency Dr. Thabo Mbeki, the Vice Chancellor and Principal of the University of South Africa in absentia, Professor Puleng Lenkapula, the respondent to this inaugural lecture, Professor Mhlanga, who is a Professor of Nanotechnology and Nanoscience from the Nelson Mandela University, Professor Tenjiwe Meyiwa, who will preside over this inaugural lecture, and she's a Vice Principal for Research, Innovation, and Commercialization and Postgraduate Studies at the University of South Africa. And of course, our celebrant who will provide the inaugural lecture today, Professor Linda Linganiso. You are welcome. And I'd also like to welcome the leadership of the College of Science, Engineering and Technology, academic and non-academic staff. And I would also pay tribute to the colleagues who have come and joined us from other colleges who are here to listen to this inaugural lecture, collaborators of Professor Linganiso locally and abroad, and members of staff from the universities and science council where she has been, and of course, the various institutes and institutions where she has served, and most importantly, her family who has joined us today. You are welcome to this inaugural lecture. And it is my pleasure today to read the citation of Professor Linganiso so that you'll know what she's all about. Professor Linda Linganiso is an accomplished academic and researcher with extensive expertise in physical chemistry, petroleum chemistry, renewable energy, and the circular economy. She is currently a full professor at the Institute of Catalysis and Energy Solutions at the College of Science, Engineering, and Technology, CSET. This is a position which she has held since January 2024 when she was appointed. Professor Linganiso's research focuses on areas such as biomass to transportation, fuels, sustainable aviation fuels, production from green feedstock via the Fischer-Tropsch synthesis. And also she focuses on the development of bio-based products from renewable resources. Prior to her current role, Professor Linganiso served as a senior advisor for resources efficiency and circular economy to GIZ, a German company, and 40% of the time she was seconded to Mpumalanga Green Cluster Agency in the province, where she has led market research, stakeholder engagements, and supported activities and SMMEs in circular economy projects. While seconded to Mpumalanga Green and Cluster Agency, Prof. Linganiso was tasked to develop a comprehensive feasibility study to set up an industrial hub to translate different waste streams from the province into commercial products. Professor Linganiso was also the Director of Research and Innovation and Postgraduate Support at the Durban University of Technology from May 2020 to August 2023, where she played a pivotal role in developing research policies, guidelines, and procedures. While she worked for DUT as the research director, Professor Linganiso established frameworks for the management of different categories of researchers at the university. Professor Linganiso has held various positions throughout the academic career, including being a professor of physical chemistry at the University of Zululand, a senior researcher at the CSIR, and a candidate researcher roles at KTS and the University of Kentucky. Her work has consistently focused on establishing research units, raising funds for projects, and supervising postgraduate students. She is currently doing an MBA in International Finance with the Edinburgh University Business School to equip herself with skills which will enable her to create financial models to sustain the Black economy. She holds a PhD in physical sciences from the University of the Witwatersrand and has contributed significantly to science literature with numerous publications and patents. Prof. Linganiso is also known for her work as a high-impact spiritual teacher, healer, and purpose-driven life coach. Her dedication to research and innovation has made her a prominent figure in her field, driving advancements in sustainable energy and the circular economy while healing the universe at the same time for a sustainable future. Ladies and gentlemen, boys and girls, it is my pleasure to request Professor Linda Linganiso to step forward to give the inaugural lecture, which is entitled Unlocking the Potential of Bio-Waste Towards a Circular Economy.
Thank you, Prof. Mamba, Executive Dean of the College of Science, Engineering and Technology, for a wonderful introduction and generosity. I truly appreciate your kind words. I wish to appreciate the Principal and the Vice Chancellor of the University of South Africa, Professor Puleng Lingambula, Professor Tenjiwe Meyiwa, the Vice Principal for Research, Postgraduate Studies, Innovation and Commercialization, Professor Bheki Mamba, Executive Dean of the College of Science, Engineering and Technology, Professor Simiso Dube, Deputy Executive Dean of the College of Science, Engineering and Technology, Professor Peter Mahwane, the Director of the Institute for Catalysis and Energy Solutions, Dr. Busiswa Ndabavacha, the leader of Waste to Energy Technology Platform in the Institute for Catalysis and Energy Solutions. Thank you so much for affording me this opportunity to present my contribution to the body of knowledge for the past 10 years or so. I also wish to appreciate my respondent for today, Professor Sabelo Mhlanga, the founder, the Chief Executive Officer, and the Managing Director of Sabinano Pty Ltd. He is also the Research Associate at Nelson Mandela University. Ladies and gentlemen, A very good afternoon to you all, and welcome to my lecture today. In the past, I've carried out multidisciplinary research. For example, my PhD at Wits University focused on production of fossil fuels and commodity chemicals. We are cognizant of the economic value of fossil fuels in South Africa, more especially considering the fact that South Africa is rich in natural endowment of coal. We are also aware of its environmental impact that we have to mitigate at the end of the day. As a result, in addition to the research work I carry out that focuses on production of transportation fuels and chemicals and clean chemicals from fossils, I have also ventured into circular economy and diversion of different waste streams into commodity chemicals, liquid fuels, as well as biomaterials and bioplastics. Today, I wish to show you how to unlock the potential of biomass towards a more circular economy. I am Linganiso. I work as the professor in the Institute for Catalysis and Energy Solutions in the College of Science, Engineering and Technology of the University of South Africa, and I'm based in Florida campus, the science campus in Johannesburg. So today I wish to take you through my research profile, and I will highlight how we synthesized nanopapers from cellulose derived from biomass, and I'll move on to talk to you about the efforts that we made to help Umhlatuze municipality generate electricity from Embangeni wastewater treatment plants. And I'll move on to show you the efforts that we made to help the sugar mills in South Africa translate different waste streams into possible value-added products. So this project was done as means to help the sugar milling industries establish sustainable business systems. And I will move on to talk about global clean technology innovation programs and leaders in innovation fellowship. These programs are offered by Technology Innovation Agency, which is an agency in South African government. And I will move on to talk about how we can unlock opportunities for consulting as academics. Because in my career, I have attracted a number of consulting opportunities without me having to go out and look out for opportunities, but opportunities do come to me. And then I'll highlight the future projects at UNISA and opportunities for collaboration. Human capital development strategy in South Africa focuses on provision of high quality education, distinctive education, and education that will sustain students in a long run. It focuses on provision of skills development and capacity building. Not only that, it also focuses on providing opportunities for employment to address the issues of unemployment as well as economic growth. I am so grateful to the institutions of higher learning in South Africa and abroad for affording me an opportunity to build and equip highly skilled human capital, the students. The students have played a significant role in my career, to a point where in 2022 I found myself C2 rated by the National Research Foundation. It is because of their efforts. Not only that, they have also contributed towards knowledge dissemination in conferences, and it is from those platforms that they attracted a wide range and a pool of local and international collaborators that today I have an ecosystem of students, postdocs, local as well as international collaborators. Together, we have published 2 volumes of Ways to Profit book. And the first volume focuses on value addition to generate wealth for a sustainable economy. So the first volume was published because we wanted to teach different stakeholders how to do much more value addition to different waste streams and generate profit at the end of the day. Whereas the second volume of Ways to Profit book series focuses on circular economy in the construction industry for a sustainable future. In the second volume of Ways to Profit book series, the mission was to train different stakeholders how to do much more value addition to different waste streams from construction industry. For example, what happens to the different waste streams after buildings have been demolished? The second volume of Ways to Profit book series focuses on teaching stakeholders how to do much more value addition as means to grow economy, to create sustainable employment and to make profit at the end of the day. Together, we have secured total funding for research and innovation of 44 million. Not only that, the ecosystem has also developed patented technologies and formulations, and we hope that at the end of the day, these patented formulations and patented technologies will be licensed in big industries in South Africa to not only revolutionize economy, but to also boost or maximize oil and gas production to improve supply. So I would like to take you through the work that was done by Dr. Asanda Mdibe. Dr. Asanda Mdibe today is working for the Council for Scientific and Industrial Research. He was my first PhD student when I worked for the Council for Scientific and Industrial Research in 2012. So Asanda synthesized nanopapers from biomass derived from maize stalk. So cellulose nanopapers have a wide range of applications, from energy conversion, storage devices, and water treatment technologies to packaging materials, as well as electronic devices. Lignocellulose biomass comes from industrial waste or forest waste. It can also come from agricultural residues. It is made up of 38 to 50% of cellulose, 23 to 32% of hemicellulose, 15 to 25% of lignin, and 5 to 13% of extractives and ash. So biomass is usually taken through alkali and bleaching treatment processes as means to extract lignin and hemicellulose to end up with individual fibers. And the individual fibers are then taken through a number of extraction processes such as physical, chemical, and biological processes to end up with nanocellulose. So in this work, which was done by Dr. Asanda Mdibe, to remove lignin and hemicellulose, maize stalk were sodium hydroxide pre-treated to get rid of hemicellulose. And it was followed by bleaching treatment process to delignify the fiber bundles. And finally, potassium hydroxide treatment process was also applied to remove further hemicellulose and to reduce the particle size to end up with the cellulose pulp. So in this kind of work, we synthesize two types of nanomaterials. We synthesize cellulose nanofibers as well as cellulose nanocrystals. Cellulose nanofibers were prepared by subjecting the cellulose pipe to mechanical blender and mechanical grinder to reduce the particle size. Whereas, on the other hand, cellulose nanocrystals were prepared by subjecting the cellulose pipe, the cellulose pulp to acid hydrolysis, dialysis, as well as ultrasonication. Surface morphologies were investigated in this work using environmental scanning electron microscopy, and the untreated samples of maize stalk displayed fiber bundles that were bonded by lignin and hemicellulose. On the other hand, the sodium hydroxide pretreatment led to defibrillation of fiber bundles as it is indicated in figure 2b. Whereas bleaching removed further the hemicellulose, leading to individual fibers as demonstrated in figure 2c. The effect of chemical treatment was also investigated using X-ray diffraction patterns, and the XRD data was quantified using a Shora equation to calculate the crystal indexes. The experimental data shows that the untreated maize stalk displayed a crystallinity of 53.8. Generally, chemical treatment increases the crystallinity of this material, suggesting that the chemical treatment does remove the non-cellulosic amorphous domain of the material. It is also important to note that the crystallinity of the synthesized cellulose nanofibers decreased, confirming the hypothesis that physical mechanical grinding decreases crystallinity. On the other hand, the nanopapers that were prepared from cellulose nanocrystals displayed three-step degradation. The first degradation step was attributed to highly accessible salvated regions of the material, and the second degradation step was obviously attributed to the degradation of cellulose, and the third degradation step was attributed to the breakdown and the oxidation of the charred. It was due to the breakdown and the oxidation of the charred residues. So thermal stability studies suggested that the nanopapers that were synthesized from cellulose nanofibers were more thermal stable as opposed to those that were synthesized from the nanocrystals. Mechanical properties of the resulting nanopapers were also investigated, and we looked at tensile strength, tensile modulus, as well as strain at break. And the experimental data suggested that the nanopapers that were synthesized from cellulose nanofibers increased significantly to 95.56, whereas the tensile strength of the counterpart was sitting at 32.77, and the massive increase in tensile strength was due to high aspect ratio. This work was done at the CSIR, as I have indicated, and it was done in collaboration with Luleå University of Technology in Sweden, and the project was funded by NRF. When I joined the University of Zululand, we realized that municipalities are owning ESCOM quite a lot of money, and we had to make efforts to help Umhlatuze municipality generate electricity from their wastewater treatment plants. So we performed techno-economic feasibility investigation, focusing on Empangeni wastewater treatment plant. And the motivation or drive behind this project, we realized from the latest integrated resource plan that most municipalities are still struggling to keep up with payments for bulk electricity purchases from ESCOM, that today the municipalities are owning ESCOM 107 billion rands. And we had to find a solution. So in this project, the data was provided by Umhlatuze municipality, and the wastewater treatment plant of focus was based in Empangeni region of the KZN province. And to analyze data, we used a spreadsheet biogas modeling tool, which was designed by the GIZ. We also used a number of mathematical and statistical tools as means to predict biogas potential yield as well as financial potential. So this project was done in collaboration with Professor Mampueli the time he was the director of the Center for Renewable and Sustainable Energy Studies in University of Stellenbosch. It was funded by NRF, and of course, I was working for University of Zululand. So University of Zululand supported the work. So based on the data assembled and assumptions that was made, it was concluded that a biogas plant would be beneficial to the municipality, and the plant was considered technically viable. So what it means is that should the municipality become interested in implementing the recommendations from the study, the municipality would benefit 3.2 million in South African rands to ease the debt burden from Eskom. This work was carried out by the student by the name Sarah Mungodla, and she did quite a lot of work. She was able to raise funding that was over $1 million during her master's work from Technology Innovation Agency and EDT. As you can see, she was making headlines during her master's program. I've taken her through different training programs. Sarah has attended Global Clean Technology Innovation Program, which is offered by Technology Innovation Agency. So Global Clean Technology Innovation Program teaches students how to refine business models. For example, at UNISA, I give students technical capabilities, and Global Clean Technology Innovation Program will teach them and give them business capabilities. She was also part of the team that went to London. She wrote a proposal that won, and she became one of the people who went to London to pitch an idea that she came up with regarding the waterless toilet system. And she did all this during her master's program. Efforts to help the sugar mills translate different waste streams into various commercial products were also made. When I worked for University of Zululand, I worked Tonga Tulet, Gledhow, Sugar Company, as well as Ilovo. The sugar milling industries have 3 different types of waste streams. They have sugarcane bagasse ash, they have sugarcane wastewater, and they have sugarcane bagasse, which we call biomass. So we had ambitions to help the sugar mills to establish sustainable business systems by doing much more value addition to the sugarcane bagasse ash, sugarcane wastewater, as well as sugarcane bagasse, which is biomass. At University of Zululand, we had a student that was doing a PhD by the name Mohumane Samson. So Samson used different concentrations of lime powder with the sugarcane ash to produce eco-friendly bricks. So we also incorporated a secret ingredient. So what we need to understand here is the pozzolanic reaction that happens between ash and lime powder. Of course, the compatibilizers were also added in the form of a secret ingredient. Polazans are broad class of siliceous and aluminous materials, which in themselves possess no properties of cement. However, when they react in the presence of water, they give rise to a composite that has got chemical and physical properties that are similar to that of a cement. So the secret behind designing the biobricks was to ensure that sugarcane ash as well as lime powder do react together and demonstrate the pozzolanic reactions. So in this investigation, the reaction between lime powder and sugarcane ash was investigated using FTIR as well as XRD to confirm that indeed there was a very strong interaction between lime powder as well as sugarcane ash. The good thing is that when we measured the water absorptivity of these materials, we realized that they comply in line with the requirements for South African national standards. Not only that, we also measured compressive strength, and we also realized that the biobricks that were eco-friendly complied with the requirements as per the South African national standard. To a point where the student who was carrying out the project is today filing a patent after refining the concept. So that is who you are. That is who we are, and that is what we do. We train students, that's number one, and we provide opportunities for them. We teach them how to solve the challenges that are perplexing the world today. At the end of the day, they come up with patented technologies and formulations, and we do hope that in the future we are going to see these technologies licensed in big industries in South Africa to revolutionize the economy of the country. We also added value to sugarcane wastewater, and this work was done by Ms. Zikhona Chemese at the Durban University of Technology. The experimental data revealed that the type of wastewater showed a COD of 5,200 milligrams per liter, which was beyond the accepted disposal range in South Africa. And we also realized that the pH range was also very, very low. So we knew that there's no way that we can use the sugarcane wastewater as it is. So Zikhona Chemese co-digested it with municipal solid waste, and this work is still in progress. So our plan is to generate biogas from sugarcane wastewater. As I've indicated to you that I also wish to demonstrate how I have secured opportunities for consulting in the past. After helping Umhlatuze municipality with techno-economic feasibility investigations, they proposed that I become a consultant without me having to ask them for such opportunities. And not only that, after making efforts to the sugar mills and help them develop sustainable business models, a proposal was brought forward for me to be a consultant in 2020. When I moved from UniZulu to the DUT, the former executive dean was willing to counter offer Professor Nokuthula Kunene and said, Linganiso, money is not a problem. I need you here. You are such a talented and intelligent academic. So I stand on shoulders of great people. I really appreciate the encouragement from Professor Nokuthula Kunene. It was after I've indicated that I'm moving on to work for Durban University of Technology to be the Director for Research and Postgraduate Studies at institutional level, and I needed the managerial and leadership experience. Otherwise, she was willing to counter offer. So I've had very good opportunities in my career, and I am so grateful for people who always inspire me and who see the potential in me. The same thing applied when I left the GIZ and Mpumalanga Green Cluster Agency. A proposal was also brought forward. At that time I was reporting to Johan. He said that it doesn't matter how many hours you want to work with us, just let us know. So they were willing to absorb me and to carry on working with me, regardless of the fact that I had already joined the University of South Africa. And upon consulting with the line manager, he told me that you are on probation period, so for now forget about consulting. So this is to say that it's very easy, to establish consulting opportunities, more especially if you review your research and ensure that it aligns with the need of society. Now, I'm very happy to highlight the current circular economy projects at UNISA and areas of collaborations where we can actually work together. I am occupying the mining, metals, and circular economy at this point in time. There is a project that I have conceptualized where we're recycling lithium-ion batteries. So basically, the motivation behind this project was the global decarbonization ambition and the need for metals. We are cognizant of the fact that there has been excessive extraction of natural resources, so we need to get to a point where we recycle the resources and the feedstocks that are actually available. So I understand the fact that in South Africa we do not have a facility for recycling of lithium-ion batteries. So I came up with a concept. So the idea is to extract valuable metals from the lithium-ion batteries, and I'm cognizant of the fact that there is a few researchers and entrepreneurs who are actually focusing on this area. But the idea is that we have already identified the gaps. So this is the project that I conceptualized in 2024 when I was in leadership and management role of the University of South Africa. So I'm so grateful that Prof. Yali agreed to take over to supervise the student who is actually coming up with the innovation. Josejo Sitikelo is the PhD student who is actually focusing on the project. We have already submitted a review, selective extraction methods and innovation for lithium, cobalt, nickel, and manganese metals from spent lithium-ion batteries. It is when we were actually doing comprehensive review, identifying the gaps, that we understood that there is a potential for the project, and Josejo managed to come up with an innovation that I think is very exciting. So the same project was used as a concept, and we applied for funding from Technology Innovation Agency, Global Clean Technology Innovation Program, and the project was selected as one of the best projects. And it's also important to highlight that recycling of lithium-ion batteries is one of the 4 pillars in the South African Renewable Energy Master Plan. So there's a plan for government to industrialize the technology. So it's a very good time and opportunity for researchers and academics to have their hands on such a project. I did not mention that we collaborate with Central South University, and I acknowledge Professor Yali for strengthening that partnership, because Central South University has state-of-the-art infrastructure for the recycling of lithium-ion batteries. The second project that is also exciting is optimization of gas, biogas production process, and fertilizer generation. When I was working for the GIZ and seconded to Mpumalanga Green Cluster Agency in 2023, there is a company by the name Gas Pty Ltd. So they contacted me because they already have the proof of concept, and the idea was to optimize it for to improve the biogas yield and to also produce biofertilizer. And the exciting thing about this project is the fact that Gas Pty Ltd has a wide range of clients for biofertilizer. This project is done by a PhD student, Godfrey Mpo Lilaga, and Professor Sembunga is also involved as the supervisor of the student. So we do hope that this project will add value to the Mpumalanga province in the space of electricity generation. Not only that, but the biofertilizer that will be sold to communities and individuals will also boost the economy in the Mpumalanga province. The third project is done in collaboration with University of Sao Paulo in Brazil. We want to help the sugar mills to industrialize biomass conversion into a variety of commodity chemicals and liquid fuels. The fourth project is upscaling a pilot. The fourth project is upscaling a pilot-scale biogas technology into an industrial plant for the city of Johannesburg, and this project is headed by Professor Baraka Celestine Sembunga. We just submitted a proposal to the DSI, so we hope that we will secure 2.5 million to get going so that we can assist the municipality to generate electricity for supply. I would like to appreciate the support that I got from the Collaborative Symposium. It's a platform that was initiated by Professor Tswafo Mutawung, and this is where we get opportunities to collaborate with young black scientists in South Africa and to also get support, because the consortium is made up of young people. When we started, I think it was 2016, we were all very young, and we've been pushing, and they really supported me. So I want to say that I am where I am today because of this platform that was created by Professor Tswafo Mutawung. In addition to that, I'm very appreciative of the institutions, the research institutions, higher education institutions, a number of people who supported me in my journey, funding entities, collaborators internationally and locally. I'm so grateful also to the University of South Africa, Professor Mamba and his team in the College of Science, Engineering and Technology. I truly appreciate the love and the support I received at CSET. Thank you so much. I truly appreciate you coming to listen to my lecture. Thank you so much.
Thank you, Program Director, and thank you for extending the invitation for me to respond and share my thoughts, after the wonderful presentation by Professor Linganiso. So, dear Professor Lenkapule, Vice Principal and Chancellor of the University of South Africa, Professor Tenjiwe, you are the Vice Principal for Research, Postgraduate Studies, Innovation and Commercialization. Professor Becky Mamba, the Executive Dean of the College of Science, Engineering and Technology, CSET, as well as the Deputy Vice Dean, Professor Simiso Dube. And ladies and gentlemen, I just want to extend my greetings and appreciation for such an opportunity. I hope you enjoyed the presentation yourself. I would like to thank you, first of all, for such a high-level presentation that has been presented by Professor Linganiso, which is very important and critical, especially focusing on bio-waste conversion into value-added products towards a more circular economy for sustainable future. Professor Linganiso's research work is quite critical because it supports the global decarbonization ambitions. Now, these are some of the challenges that we face globally. It's not surprising that indeed the world is facing serious and formidable challenges that relate also to energy as well as waste management that has become a burden to our environment. And so it is an honor, therefore, to be a part of this important event. And I must just start off by saying that I first met Professor Linganiso over 19 years ago at Wits University when I was a student there. So we both were in a group called the Catalysis Organomaterials and Materials Group, which was led by Professor Mike Scarrell and Professor Neil Colville. And so you will see that Prof. Linganiso has continued to focus on materials, but more prominently, you've seen from the presentation that a focus has been on beneficiation of waste materials into valuable products, which would help us to solve many problems that we face in relation to energy. So a PhD work at Wits, I'm just recalling this because I'm intrigued that it's still linked to the foundation that she received there. So it focused really on catalyst design and of various catalysts to produce the transportation of fossil fuel-based fuels and clean chemical products, which were achieved through Fischer-Tropsch synthesis using microwave pretreatment. So Linganiso's PhD was and is still critical for the economic growth of South Africa. As we know that South Africa is rich in natural endowment, especially of coal. And the economic impact of South Africa's natural endowment cuts across different sectors of industries, from energy production, export revenue streams to creation of sustainable employment and infrastructure development. Therefore, the demand I'm sorry about this, the demand for South Africa's transportation, especially of fuels or synfuels, has been skyrocketing. And not only this, but South Africa in general as a country has made significant strides in promoting exploration of natural endowment of coal to transform the economy through designing of state-of-the-art infrastructure. Which made her findings, to be relevant to boost the economy, as well as to maximize oil and gas production from financial gains. So from her work, Prof. Linganiso has didn't just publish papers. You can see that from what she has shared, she has published and even produced a patent, for example, from her research. So as role players in the higher education institution, we are cognizant of our role in the national system of innovation to bring about transformative innovations which will revolutionize the economy in the energy sector and to maximize oil and gas production. Prof. Linganiso has demonstrated that her ambitions do not just seek to do this, but we therefore seek, to look forward to some of her innovations that will transform the energy industry in South Africa, as well as the African continent at large, so that we move towards a more sustained economy. So Prof. Linganiso has since redirected her efforts to the development of value-added products from waste streams to support the Department of Science and Innovation's bioeconomy strategy, as well as the global the global waste economy strategy. Obviously, she's done this by unlocking the potential of bio-waste materials towards a more circular economy. So through research publications and as well as presentations in various platforms, and of course through the local international collaborations that she has demonstrated, it clearly shows that Prof. Linganiso is not just focused on the scholarly work for her own research group, but really has focused, has projected towards international collaborations. And you can see that she has networked and established some collaborations with countries such as the United States of America, India, Brazil, China, just to name a few of them. Vice Chancellor, I do want to highlight, that indeed the circular economy is a global hot topic. So transitioning to a circular economy is a future that we cannot afford to delay. And I'm saying this because the issues that we face, for example, from the loss of biodiversity to degradation of the ecosystem and mounting waste, these are issues that actually result to consequences that may be negative. And would suggest that if not properly managed, we can have issues, in the way in which we deal with the economic challenges that relate to waste. So, but there is, of course, an urgent alternative, that one has just been presented. And of course, the circular economy is more than just an environmental fix. It's a smarter, more resilient strategy for sustainable development, and it has the power to revolutionize how we produce, consume, and thrive within the planet's limits. So this would be a most critical economic transformation in our era. Prof. Linganiso's 13 years of experience in the circular economy, bio-waste beneficiation remains relevant. So she has demonstrated that from 2013, she has secured a significant funding, especially I noted funding from the Development Bank of Southern Africa, and she has also initiated an agro-waste beneficiation project through collaboration or for the CSIR. And where several prototypes for automotive and aerospace industries were developed by the research team, she established through research and innovation. So Prof. Linganiso, while at the CSIR, and through that collaborative effort, she did not only secure the Green Fund, but she has also managed to include and involve students which have completed their higher postgraduate qualifications, and of course, who have also published their research in many articles. Prof. Linganiso also highlighted some various aspects of her research, including some collaborative work within the KwaZulu-Natal province, specifically since joining the University of the Witwatersrand. She has demonstrated some of the work that she has done there with the University of Zululand, and which involved circular economy projects in partnership with the sugar mills in the area. And you can see that the idea behind her research is to involve even previously disadvantaged institutions like the University of Zululand, and of course, strategically also focusing on those areas which have a wide, supply of bio-waste materials, like your sugar mills in the KwaZulu Natal region. So you will see that most municipalities, Vice Chancellor, at this time and age, in fact, recent reports have shown that municipalities fail to keep up even with paying their debt, for example. And the burden is actually currently sitting at 107 billion, and it's most likely going to continue to rise. So the framework for some municipalities, especially those in the rural areas, is unviable, and it poses a serious risk to their financial sustainability. This debt is snowballed by the 28 billion snowballed from 28 billion in March 2020, and it continues to rise. So this is an overarching crisis which needs urgent attention. The Mkhathuze municipality has more than 8 wastewater treatment plants, and Prof. Linganiso's techno-feasibility investigations to evaluate the possibilities of electricity generation from combined heat and power integration to biogas technologies speaks volume and has proven to be a solution for local municipalities, which they sought after. And so it is quite interesting to see these developments with Prof. Linganiso forming a core or an important part of those ambitions to solve energy issues within the local municipalities. I do want to also just mention, some of the key aspects which she has mentioned. For example, after value addition to sugar wastewater as well as sugarcane ash, it is also, been an interest that the sugar mills extend their proposal and focus more on people that would understand or develop models in which sugar bagasse or waste ash can be beneficiated. And of course, Linganiso has been at the forefront, and of course, when she recently joined, I've seen that in recent years. One of the projects is actually one of UNISA's flagship projects, which involves the Institute of Catalysis and Energy, which focuses really on waste to energy which she does with her colleagues, particularly Dr. Busiswa Ndabavaja. Madam Vice Chancellor, I do want to also mention that apart from the fact that Prof. Linganiso has done all this research or has clearly crafted, a research focus area with impact. I do want to applaud the fact that she doesn't do her research without problems, because in most cases, researchers will do the research in the lab or within their research facilities without a problem to solve. And so the research at the end of the day becomes meaningless. But Prof. Linganiso identified all the problems and focusing on those problems and developing solutions that will have an impact. So apart from the fact that Prof. Linganiso has already edited, 2 volumes of waste to profit books, it's quite interesting to see this, because it clearly shows that the knowledge that she has an experience that she has, harnessed over the years, she is able to publish it in 2 books. Specifically, one of them looks at value-added products for sustainable economy, and the other one focuses on circular economy, especially in the construction sector for a sustainable future. So Linganiso's projects, and specifically this project that relates to waste to energy technologies, will help, the consortiums as well as the municipalities to fast track the development of power energy, as well as building waste to energy industries to create sustainable employment and economic growth for resilient cities, towns, as well as improving the lives of people, especially those in rural communities. So I've seen that Prof. Linganiso's strategy really, as a research professor, and as you would expect, is that she has the heart and she really is all out to train students, postgraduate students, and she has demonstrated that she's able to push them to think critical and be innovative in the way that they develop their projects. And of course, one thing that I would probably have noticed from her presentation is that is the Global Clean Technology Program, which is offered by the Technology Innovation Energy. Now, this is another brilliant strategy for transformation, particularly for human capital development, because it's not only just to give the students industrial experience, but also to equip them and engage in economic activities of the country during and after their study. And this is also in line, with the aspirations for the Department of Higher Education and Training, which seeks to drive entrepreneurship development within universities. And of course, the whole idea is that we need to be at the forefront, especially in Africa, as a country or as institutions that are at the forefront of being entrepreneurial and allowing those spin-offs. Of course, this remains a challenge for many institutions, and want to believe that with the caliber of people like Prof. Linganiso at the University of South Africa, we'll begin to see spin-off companies, or we begin to see the university approaching, strategies that are more entrepreneurial rather than entrepreneurial. And by entrepreneurial, I mean that the university supports the researchers or the innovation within and creates companies or spin-offs which they've become ownership, or they become owned by the universities in partnership with the innovators. In that way, many barriers that would struggles that an individual entrepreneur would have can be overcome as such. So I do want to applaud and say that, look, Prof. Linganiso is not just a person that has focusing on teaching and learning, but her result, her work has been eminent from the produced graduates, some of whom are consultants, some of whom are entrepreneurs, others are academic and researchers working in different research entities and universities, but it really depends on what they want for. So they were all of these, of course, are trained and primarily with the focus to have those solutions that relate to energy. So I want to end by saying that Prof. Linganiso so rightfully has established herself, and I can say that and congratulate her for being, promoted and appointed as a full professor in the College of Science, Engineering and Technology in South Africa, and I can wish her the best. And I want to believe that she's going to add value, continue to add value to the university through internal collaborations, both with her academic peer researchers, as well, of course, with the leadership of the university, as you expand and make those global collaborations and have an impact on the topic that relates to the circular economy. So thank you so much for allowing me to share my thoughts on Professor Linganiso's presentation, and I would like to wish you all a great day ahead. Thank you so much.
We're now closing. We thank you for the chat box congratulations, but I saw less of the research questions and references to Prof. Linganiso. We have to thank Prof. Linganiso for an educational lecture that is an acknowledgement and an extent of her scholarship, and indeed a testament of the significance of her scholarship. Through this lecture and its analysis, we are very wiser than we were before we got to this installation and to listen to this lecture. And we must thank Prof. Linganiso's family for attending this lecture, and everyone, each and every one of you, and doing so into the evening and on a weekday for that matter. Prof. Mhlanga, our respondent, thank you, sir, for the work that you've done and for the highlights you've brought to our attention. Ladies and gentlemen, we are towards the end of these proceedings, and as I end, I want to also thank colleagues that have not had a privilege and opportunity like me to come to the podium and be part of this lecture. These are colleagues who are behind the scenes, who make such lectures a success, and we want to thank them. These are colleagues from the Institutional Advancement Portfolio at the DIA, that is a Department of Institutional Advancement, the multimedia colleagues, the video recordings experts, the IT experts, and all the colleagues that have been behind the scenes for you to get to experience this lecture in the fashion that you have experienced it in this excellent state. Thank you again. Good evening.